Good morning and welcome to the Learn C Like It's 1996 series. Today we're going to have some distractions because apparently I have a professional upstairs neighbor, so they're doing some renovation works in the morning. Also, you may occasionally hear me eating cereal because I still haven't had breakfast and I'm hungry. Anyway, yesterday uh, while we were writing some code in very old C, we encountered problems with LSP because the clangd LSP defaults to using just the default compiler settings, and this was incompatible with NSI. So basically, what do we have here? Okay, I had to define a clangd file to set the default compile flags for clangd LSP, and lo and behold, now it does not complain about the getline definition, and it still works. It just says that multiple different client offset encodings detected for buffer. This is not supported yet. I don't know where this warning comes from, but I may go and try and debug it sometime later on. And this book. So in the previous video we arrived at this we arrived at this. Where was this? Okay, we encountered this exercise 116 and revise the main routine of the longest line program so it will correctly print the length of arbitrarily long input files and as much as possible of the text. So the way I solved it in the previous video was just by using the standard library, the GNU standard library, or like modern C. So we had the getline function from the POSIX standard library, and it handles arbitrarily long input lines on its own. But I thought this was kind of like cheating, because this was not what Kernighan and Ritchie meant. So I'll try and actually fix it so that if we so currently what do I have here? So currently, if we try to compile it, okay, I have in the make file I need to define compilation flags. Okay. What? Like this, maybe? Okay. Yes, so cc equals clangd, maybe, as well. Yeah, so maybe at some point we may want to consider using clangd for compilation, because we are currently using GCC, which I guess may be fine. I don't know. So okay, the program is compiling using the ANSI flag. and what do we have? It's compiling with the unsafe flag, and it's working correctly for shorter lines, and for longer lines we wrote a program that would repeat a string. So it was basically a very simple for loop. So now I compile it. GCC, okay, yeah, okay. Repeat. So this basically prints 1500 A letters, and if we pass it to longest, it only prints the first 1000 characters because of the way it is. Oh, it prints 999. Okay, so we wanted to be able to print. It currently only prints the first 999 characters and the null terminator because we defined a buffer to have a maximum. It is statically allocated. It is allocated on the stack, so it cannot grow, it cannot shrink, it's just there. The length is defined at compile time, which is not ideal for this situation, but anyway, the goal is to keep to wait, okay. You basically need to, as much as possible, on the text. Okay. Yeah, why does it say we have to modify the why does it say we have to modify that? Okay. I don't think we can just only modify the main routine. We would also have to modify the getline function, and wait. So just let me reiterate. The book tells me to modify the main function. I can fix this just by modifying the main function. I would probably have to also fix the getline function, and I'm not entirely sure how they want me to do it. And okay, so basically this this function iterates it reads the next line, it starts from 0, it goes up to limit -1, and then it stops when it encounters end of file or a new line, this loop at least. And so I would have to do something like iterate until you reach end of file or new line. If there is still space in the buffer, if there is still space in the buffer, store the last character. So at least that's my idea. So we could do something like for I equals 0, I is less than or equal. No, we don't care about the limit in here, right? So we could do something like for I. Okay, we do not initialize I, and we iterate until we get to is not end of file, and C is not equal to new line I++. Okay, yeah, something like this. We could just skip ahead until the end of the line, and yes, so we still need to print and add a null terminator in there somehow. Wait, what? Okay, get char. I'm not entirely sure. So basically, we iterate until we reach the end of file. Okay. So, okay. If the last character we encountered was a new line, this means this is a happy path. We had enough space to store the false string, and if there wasn't, we go ahead until we encounter the new line. And so the unhappy path is the line was too long for us to store the new line, the whole string and new line. Okay. Okay, so if the string was too long, we have to add a, okay. Okay, if we had enough space to store the whole string, we do these things. If we had enough space for a whole string, we add a new line at the end, and then we add a null terminator at the after the new line. And if the line was too long, we skip ahead until we find the actual new line or end of file. Oh, wait, I have to take a and then we add we know when the string will end because we know the limit. So as limit -1, limit will be max, so equals new line, and as limit equals 0, like this. No, this will be limit -2 will be new line, and limit -1 will be 0. Okay, like this. And then we can return the correct length plus 1, or something like this. Plus I. Okay. Okay, this is pretty convoluted, and hopefully we will not have to do it anytime soon anymore. But let me see first. So the way this works right now is it returns the way this works right now is it returns the length of a string. It returns the first 999 characters, and if you run it against its own source code, yes, so we want, this seems to be correct, right? We made longest answer. Okay, and now we are in an infinite loop. Great. And I played myself. So what actually happened? Else if C is not in the file, maybe like this. Yeah, this still works. But does it work with the repeater string? Okay, so it still prints it still cuts the string. I think it's even shorter now. Okay, it's the same length, but we get a new line at the end. And so wait. So now let's see if we can also get it to print the length of the string like this. So maximum make longest ANSI. Okay, so this seems to be working the way I intended it to. It does print the length of the longest string, and it does so it correctly finds the length of a string, and it's probably still it seems to be still working fine with like shorter input, and hopefully I don't have to write anything like this too often. Okay, yes, good. So enough for the detour. The task was to fix the new line so it will still return the correct line length even if the message overflows the buffer, and I think we got it done. And the solution was to seek until end of file or until a new line, and yeah, basically add a new line and zero terminator at the end. Okay, great. Write a program to print all input lines that are longer than 80 characters. Okay, this is more like grep. Now the question is, do we want to use it? Do we want to do it with actual POSIX, or do you want to remove trailing blanks and tabs from each line of input, and to delete entirely blank lines? Yeah, I guess maybe. Okay, so write a program to print all input lines that are longer than 80 characters. I'm going to start with a new file. I'm going to call it threshold C. Okay, we can save it. It's here. Okay, include standard IO int main. So we could probably, I don't think I want to keep using the like the homebrew version of getline, and I'm not sure if we're going to be using it a lot later on, or yeah, we're going to be using getline a lot, so I'll just okay, yeah, I'll just keep using the homebrew version. Int getline, and what was the definition in here? Getline like this. Okay, do I get string copy? I'm not sure. In getline, and then in getline char line int max line. Okay, and the buffer will be 1000. Okay, the max line. Okay, so in here in C and I, for I equals 0, I is less than limit -1, and we are not at end of file. And we are not at new line. I plus that did we actually say I plus plus or I plus plus I, because they're usually I plus plus I people, yeah. Plus plus I. S of I equals C. Oh yeah, okay. If we are at new line, S of I equals C plus plus I, like this. S of I equals 0. Okay. And then return I. Great. So this was the getline definition from there. And then do we have str include string h? Can we get string copy? Okay. Int length. Do we need it? Yes, I think we need char line max line. Actually, we probably don't need it. Okay, great. While length equals get line max line is greater than 0 if length is greater than the threshold. I'll set it to something shorter for now. If length is greater than the threshold, printf s and line. Okay. And then return 0. Make a threshold. And then threshold with its own source. Okay, if I change the threshold, yep, that looks legit. If I change the threshold to 50 characters, we only get this one line, and I guess this may be the only line that's actually longer than 50 characters. But if I change the threshold to 15, then we have quite a lot of longer lines. Okay, great. So this seems to work, and we are still using the homebrewed implementation of getline, which I guess is going to happen quite a lot in this book. And you know what, maybe I should even also try to make an implementation with like modern C. Yeah, I'm renaming it to threshold and C, and I should unignore clangd, and I'll make a directory just for ANSI files. So this, and this. And I can delete this file, I can delete this file, I can delete this file, and I move this one here. So in thresholds.c, I'm going to use modern C. Okay, so getline is working great. Int main, int length, no, it was a size t, length equals 0, and we define a threshold at 30 for now, and then we had a char line equals null. No, okay. We will have to, okay, yeah, we'll use a null pointer for now. I'm pretty sure this may be memory safe even if we repeatedly define it like this. So while and red equals getline and line, and then length, and we read from standard input. Okay, okay, size t and red. Oh yeah, this is actually the length of a buffer, so we still need to define it, but we don't have to act on it, right? It's not -1. Okay, if n red is greater than or equal to threshold, then we print the line. Return 0. Okay, let me see if this works. Yeah, it seems to work. Will it work with the ANSI? Yeah, it seems to do exactly the same as the previous implementation with wait, what, 50? Oh, we said the threshold at 30. Let's say, I think we started with 50 at first. Okay, so now it does exactly the same as the previous implementation, and we forgot to free, which probably wouldn't matter in this particular program because everything will be freed after main exits, but we should make a habit of freeing buffers nevertheless. Otherwise we will be just leaking memory. Yes, going back to exercises. Write a program to print all input lines that are longer than 80 characters. I did it with 50. Anyway, 80 is not a magic number anymore now that we are not working with punched cards. Write a program to remove trailing blanks and tabs from each line of input and to delete entirely blank lines. Okay, so for this one, I actually probably wouldn't even want to use getline. I mean, we could, but we would have to do 2 passes because we need to. Oh, and we need to keep track of if this was trailing or not. And I'll probably just start with okay, I'll start with ANSI, with modern C. Int main I think our function could be basically returning a flag saying if a line should be printed. So bool get line no trailing, and then we have a destination which will be a buffer, and then we define a limit. Okay, so what did you call it in the previous videos? Called it max line. Okay, maximum buffer size. Okay, char line is max line. Okay, and then we need to somehow indicate whether we actually need, I think we need to return values. We need to know when we got to the end of file, but we also need a way to indicate that a line was empty but we shouldn't print it. And this to me sounds like to return values or some special values on returned from this getline no trailing. And yeah, I guess maybe we could just return a flag like this. So I think it was an int. So we can say getline no trailing char buffer and int limit. Okay, so we start by defining the last character and the iterator variable, and then for we start with I equals 0, I is less than or equal to limit -1, and C equals get char is not an end of file, and C is not a new line, plus I. So we do the same as we did with over there, and entirely blank lines. I think this just means that the line was just a new line, so we can just I don't think we have to do anything this complicated, and Oh wow, this is more complex than I thought. So we know okay. Yeah, okay. Let's say if you encounter a space or tab, first check, ignore it at first, and okay, I guess, and last non-wide index equals 0, or even -1, like this. Okay, so if we encounter a space, we can see when the last time we encountered a non-white space character was. So, and only so we could basically just say if we encounter spaces, we will copy them to the new, copy them to the line, to the buffer, but keep track of the last non-white index. Okay, so if the C is a space or C equals a tab, okay, if it's a non new line, then we keep the last non-white index equals I, and okay, I guess. So then when we encounter the what did we do in the previous implementation though? Longest. So yeah, so basically at the end we can treat the last non-white index as if it was just this. So after we have read all the characters, revert to last non-white index, and then if C C equals newline, like there. C and okay, if I okay slash now at index, okay, and C of I equals newline plus I, C of I equals null terminator, like this. Okay, no, okay, that's buffer. Okay, and then we also copy buffer of I equals C, like this. Return I. Let's see if this even compiles. Make trailing. And then we use a like this. We pass a string with some trailing spaces. Oh, and we also need to print it. Okay, so while int length while length equals getline no trailing, we pass the length and we are using our own getline, so getline no trailing and then line, and limit is max line is greater than 0. Printf line return 0. Okay, like this. Okay, so it seems like it's truncating the last character. Plus 1. Yeah, so let's see. And what if I have some more spaces trailing? Okay. Okay, so now it also removes those trailing spaces. Okay, so this handles the case when we this handles the case if the line ends in a new line. But what if we want to handle like the end of file or overflow? And okay, but it doesn't matter. We are only reading until the limit. So I guess it didn't say we have to also handle we also have to handle the overflows. Okay. If we only print it if length is greater than 1, right? And do we have any empty, we have some empty lines in here, so trailing from trailing.c. Yes, so it removed new lines. Great. And I'm thinking that maybe we could also try to do this with getline. So trailing with getline. Where is my buffer? Okay, like this. Include standard IO and int main size the length buffer size the we don't need the length. Okay, char line equals null. Okay, and then while we read each line, length equals getline line and buffer size, and then from standard input size t number of red bytes. Okay, while number of red bytes yeah, we could store it in here. If n read is less than 2, we continue, because we can basically just skip a line if it's just 1 byte, right? And print first. We just print the line without checking, without removing trailing spaces, right? Return 0. Make trailing with getline, and then we can do the same. We are still getting removing new lines empty lines correctly, right? So so now we can so now we can try to find the last index. Okay, so int last non-white equals -1 for int I equals 0, I is less than or equal to number of red plus I, char C equals line of I if C is not a space and C is not a tab. Last non-white is I, and yeah, so basically we try to find the last index of a non-white character, and if there is none, if last non-white equals -1, we continue. Otherwise, we somehow want to slice the yeah, so basically we just want to slice the string somehow. And then for int I equals, we have to iterate until the end of the, oh shit, I forgot to charge my computer. Wait. It probably doesn't matter. We only have a few minutes left. Anyway, we have to do several runs over every single line because we are using getline, and then we do one more run to find the index of the last non-white character, and then when we know the index of the last non-white character, we can int I equals 0, I is less than or equal to last non-white, yes, plus I, and put char line of I, and then put char new line like this. This is, let's see, oh, we now get even more new lines than before. Great. Why is that? We only have this put char. And C is not a new line, right? Okay. Yeah, so now we are getting the same result, and we could probably also, this would probably also ignore the lines that are it should probably also ignore lines that are not completely empty but also have some sort of like trailing spaces. I cannot do it in Vim because it will just remove the space, so I have to do it with something like Pluma. Do I have Pluma? Do I have gedit? Trailing getline. See? Okay, so I'm going to, yeah, this is, yeah, I'm in column 8. So it's still correctly removed all empty lines because we know that it's not very optimal because we are doing several passes over every single line. But if we want it to be really memory efficient, we should probably do something like read ahead if you find we only keep the buffer, or yeah, whatever. Maybe reading it line by line is not so bad. Anyway, this was much more complex and difficult than I have thought. And we still have one more exercise left. Okay, we did 117, 118, and then we also have 119 left. And I know this can be tricky with modern texts, because in modern texts in UTF-8 you can you get texts, you get characters that are that are longer than just 1 byte. So it would probably completely break if I tried to do it with a UTF encoded string containing anything else than ASCII. But we'll see how it turns out. And in the meantime, I hope you enjoyed seeing me struggle. And I will see you in the next video. If you have enjoyed it, please like and subscribe. See you.